Midpoint circle drawing algorithm. It is proposed by Bresenham himself. So it can also be asked as Bresenham's midpoint circle drawing algorithm. For this one input we need radius r and center xc, yc, any center. But the first point what we are going to plot will be x0, y0 equal to 0, r. Because this algorithm considers a circle centered at origin, and a circle will be drawn on the upper half of the first positive quadrant. So you have xy quadrant where you have first, that is, it's a positive quadrant, right? So on that upper half is the first octant under this consideration, positive octant. So you have to calculate the initial decision parameter using either of this formulae. But the thing is, if r is not integer, you can take this formula. If r is integer, 1 minus r you have to take. And at each step, if decision parameter p is less than 0, you are going to increment the x-axis, whereas leave the y-axis as it is, and calculate the next p value using this formula. Otherwise, means if p is not less than 0, you are going to calculate the next point by incrementing the x-axis or x-coordinate value and decrementing the y-coordinate value. Why we are decrementing is, I am going to take the octant of the circle in this section and in this direction. In this direction, as you can see, the y-axis is reducing, so you'll have yk minus 1 set for the y coordinate, and this is the formula for calculating the pk plus 1. Next, this step is to calculate the symmetrical points. I have given you the figure of symmetric points for circular path, and once all of them are calculated, we can move this entire circle to the given center xc, yc we have taken it at the beginning by shifting the entire circle to the required position by incrementing all the x and y axis value with the given center value. So x plus xc and y plus yc will give you the resulting vertex values for the given circle for the given center. And this has to be repeated for until x becomes equal to y or x becomes greater than y value. So as an example, I'll take radius equal to 7. So the first point to be plotted will be equal to 0, 7 from the algorithm, 0, r, 0, 7. So this is my required pixel positions starting from the origin 0, 0, which is said to be the center vertex. 1, 2, 3, 4, 5, 6, 7, because 7 is the radius. So along both y and x axis you are supposed to plot. In test, use the scale and draw equal distanced pixels. First step is to plot the first point 0, 7. So I'll be plotting 0, 7 here. This is the 0, 7 pixel. So we are supposed to calculate the required value, that is the decision parameter. Since r equal to 7, I can take p equal to 1 minus r. So p naught equal to 1 minus 7 equal to minus 6. Next, the steps continue. We are supposed to check the value of p and then proceed with the steps. So is p naught less than 0? Yes, p naught is less than 0. If p naught is less than 0, the next point will be incrementing x-axis and leaving the y-axis value as it is. So the next point, the initial point was 0, 7. Next point is incremented by 1 for x coordinate, and y will be remaining as it is. So I'm supposed to plot 1, 7. 1, 7. This is the second point. Next, calculation of next p value. So P1 equal to, what is the formula? Pk plus 2xk plus 1 plus 1. So this says that I am supposed to multiply the new value of x with 2. Okay, so what is the existing value of P naught? So P naught plus 2 into existing value of x is 1 plus 1. P naught is minus 6. Minus 6 plus 3, which is equal to minus 3. Next, same steps. Is P1 less than 0? P1 is equal to minus 3. Yes, it is less than 0. So the next point is going to be incremented by 1 for x coordinate, that is 2, and y remains as it is. So 2, 7 is the next point. 2, 7. Calculation of next P value. P2 equal to P1 plus 2 into same formula. Previous is less than 0. This is also less than 0. Same formula will be applying. 2 into current x value is 2 plus 1, which is equal to P1 was minus 3. 4 plus 1. 5 plus 5. So it is equal to 2. Now, previous value of P is P2. You're supposed to check, is P2 less than 0? P2 is equal to 2, as you can see here, 2. It is not less than 0. So you're supposed to go for the second otherwise condition. When it is not equal to 0, it's going to increment the x-axis or x-coordinate value but decrement the y-coordinate value. So here the next point will be, what was the previous value of x? It is 2. It's going to increment the x value, so 3, and decrement the y value. Previous value is 7, now it will be 6. I am supposed to plot 3, 6. So 3, 6. This is the point to be plotted. Next, calculate P3. Now P3 equal to, P2 was not less than 0, so you're supposed to go for the second case. So P3 equal to P2 plus 2 into latest value of x, 3, plus 1 minus 2 into latest value of 6. Sorry, latest value of y, which is equal to 6. P2 is equal to 2, then plus 6 plus 1 minus 12. So 8 plus 1, 9. 9 minus 12 is minus 3. P3 equal to minus 3. Now is P3 less than 0? P3 equal to minus 3, which is less than 0. You're supposed to go with the less than 0 condition where it increments only the x-axis. So the next point will be 3, 6 was the previous one. Now we'll be incrementing only the x-axis for 6 as it is, and plot 4, 6. And calculate P4. When it is less than 0, P4 equal to P3 plus 2xk plus 1 plus 1. So P3 plus 2 into xk plus 1 is 4 plus 1, which is equal to P3 was minus 3 plus 4 to the 8 plus 1, 9. 9 minus 3 is 6. Is P4 less than 0? P4 is equal to 6, which is not less than 0. So the next point, according to not less than 0, the next point is going to increment x coordinate value and decrement the y coordinate value. So previous x was 4, now it will be 5, and previous y was 6, decrementing you'll get 5. So 5, 5 is the next pixel. So 5, 5. So as you can see here, you have x equal to y. According to the condition of the algorithm, if x greater than or equal to y, we have to stop the processing. So we can stop our answer till here. So this is the top octant and in the positive quadrant that is generated by the midpoint circle algorithm. If you see the diagonal line here, 45-degree line, this point is common for both. Okay, so this is where it stops. Now, just in test or exam, you're supposed to highlight the points which will be generated with the help of the symmetry. So you have to take the formula like in the octant that I had given in the class. So in the top quadrant, you had the value y comma x, and in the below quadrant you had the value x comma y. Okay, remember this is x comma y, this is y comma x. According to this rule, whatever y value is here, this will become the value of y axis. I mean, whatever x value is here, that value will be the value for y axis, and whatever y coordinate value is there, that will become the x coordinate value. So what are the points taken? 1, 7. First one plotted was 0, 7. You need to represent it separately in the answer. I'll write it here only. So in the below quadrant, you are supposed to highlight 7, 0. So you'll get 7, x-axis 7, and this 0 as the symmetrical point. And in this one, 7, 1. So 7, 1. Then you have third point, 7, 2. So 7, 2, this one. Then you have next point 3, 6 means in the symmetric point it will be 6, 3 for this octant. So 6, 3, and here 4, 6 means 6, 4. So 6, 4. Six, 4 will be here. So this is still where you are supposed to generate the pixels for exam or test. So just you can list out symmetrical point are these, and in sequence you can write these values and highlight in the figure.